we're going to find all solutions for z to the power of 4 equals negative 16. In other words, we're doing the fourth roots of negative 16. All right, so using de Moivre's theorem, we're going to use this part here. So if we let c equal r times cosine of theta plus I times sine of theta, that means our r has to be positive. All right, so we have z to the power of 4. So according to de Moivre's theorem, that's going to be r to the power of 4. And we're going to have cosine of 4 theta plus I times sine of 4 theta. All right, now what we have is negative 16. That's going to equal 16. And again, we need all solutions. So basically, if you look at negative 16 plus 0i, if you look at it on the graph, that's somewhere over here, this point here. So this angle here is pi. So that would be our solution, but we need all solutions. So what we're going to do is take 16 times cosine of 2n pi. That gives me all the rotations. And then we're going to have plus our pi. Now, you have to add your sine and do the same thing, n pi plus pi. This is for all solutions. Now, our n is an integer. So let's just say n is integer. All right. Now that we have that, what we're going to do is look for our r. If this is 16 and this is r to the power of 4, our r equals 2. And then remember, it's not negative 2. Our r has to be positive. I know that's kind of confusing part, but r has to be positive. All right. Now, what we want to do is match up these angles. 4 theta, we're going to match up to this, because we're trying to get all solutions. So we're going to do 4 theta equals 2n, 2 pi n plus pi. I can just rearrange it. And when you solve for theta, you're going to get theta equals, you divide both sides by 4, you're going to get n pi divided by 2 plus pi divided by 4. And I can simplify this by getting my common denominator as 4 and factoring out a pi. That's going to give me 2n plus 1 times pi. Now that we have that, let's write our new equation as z equals 2, that's your r, times cos of your angle. Now your new angle is 2n plus 1 times pi divided by 4. All right, and then do the same thing, plus I times sine of 2n plus 1 times pi divided by 4. All right, and this is for, since we have 4 here, the fourth roots, our n is going to be 0, 1, 2, and 3. So on the next slide, what I'm going to do is substitute in 0. You're going to get pi divided by 4s. We're going to get a lot of pi divided by 4s. So basically, you want to maybe copy this down, and we're going to go ahead and start with this. So we're going to get first for n equals 0. That means we're going to have c equals 2 times square root of 2 divided by 2 plus square root of 2 divided by 2i. What happens is that these 2's will cancel out. So this is going to give you square root of 2 plus square root of 2 times I. All right, now we got to go all the way to 3. So n equals 1. This is going to be z equals 2 times negative square root of 2 divided by 2 plus square root of 2 divided by 2i. The 2's will cancel, so you get negative square root of 2 plus square root of 2 times I. Now let's try n equals 2. That one's going to give you z equals 2 times negative square root of 2 divided by 2 minus square root of 2 divided by 2i. The 2's will cancel out, so we're getting this. We get our 4 different solutions. And finally, n equals 3. That's going to be z equals 2 times square root of 2 divided by 2 minus square root of 2 divided by 2i. This is going to give you square root of 2 minus square root of 2 minus square root of 2i. Forgot my I. All right. So your 4 solutions are all right here. C equals these 4 solutions here. Thank you. Have a nice day. Bye-bye.